Hyperbolas have another property than other conics do not have. They do have asymptotes. We can't discover those asymptotes by examining the graph, but we can discover them by looking at the equation. So let's look at the equation of a hyperbola with center at 0, 0 and foci on the x-axis. If we solve this equation for y, then we'll get equation y equals plus or minus bx over a times square root of 1 minus a squared over x squared. The process of solving that equation for y is shown right here. Now what can we say about that expression? What can we say about that value of y? If x has a large absolute value, it means x is a large positive or large negative value, then x squared is going to be large number, and therefore the whole expression a squared over x squared will be small because its denominator is large, and therefore the expression within that radical is going to be close to 1 for x is really large. And that means that the y on the hyperbola will be about plus or minus bx over a for a large enough. And that means that the values of y are close to the values of plus or minus bx over a, which are on a straight line with the slope plus or minus ba. And that means that we have two asymptotes. One asymptote is the line y equals b over ax, and the other one will have the slope negative b over ax. So the slope for the first line is b over a, slope for the second line is negative b over a. Both lines have y-intercept 0, and therefore they will pass through the origin, and that means they will pass through the center of our hyperbola. It is easy to graph those lines. Once you have values of b and a, we use the fact that the slope is rise over run, and we use the fact that the point 0, 0 is on the graph. So we'll have the point 0, 0, and now we'll rise b units and run a units, and we'll end up with the point A and B. Notice that A is the x-coordinate of the vertex, and the line is going to pass through those 2 points, 0, 0, and the point A and B. On the other side, we'll get a point on this line. Point is going to be negative A and negative B. To get the other line, the slope is negative b over a, so we'll rise negative b units, so we'll go to the negative b on the y-axis, and we'll run a, which will end up at the point a and negative b. Again, x-coordinate of that point is the vertex, x-coordinate of the vertex, and we draw that line. Once we have those lines, you can see that indeed the graph of the function approaches those lines. First line was the line with the slope b over a, and the second one was the line negative b over ax. So as you can see, the value of b is used here to draw those asymptotes. Now notice one more interesting thing about those asymptotes. If I draw a rectangle going through the b on the y-axis and a on the x-axis, so going through those 2 points and having the sides that are parallel to the x and y-axis, you will notice that the points through which those lines pass are vertices of that rectangle. Often this rectangle is called the hyperbola rectangle. Okay, these are the points through which the asymptotes go, and they are formed by simply drawing this rectangle. So the value of A and B, once we have value of A and B, we can draw the rectangle, we can draw the lines, which are really extension of the diagonals of this rectangle. And once we have the asymptotes, we know where the vertex is, we can draw the graph of the hyperbola. And we'll use these properties to graph hyperbolas.